My name is Kelly Paffel, Technical Manager for Inveno Engineering, LLC, located in Tampa, Florida. Today I want to talk about steam valve internal leakage detection and testing methods, part 2. Specifically, I want to talk about testing methods. Isolation valves, which we'll talk mainly about today, using a plan to isolate different segments of the process systems for different reasons. Internal leakage will prevent the system from being isolated and possibly lead to a total plant shutdown. There are so many times that we get into trying to shut down a segment of the plant, we cannot find a valve that does not leak through, and we're ending up shutting the plant down. Before a major outage or a unit shutdown, we want to go and determine which valves we need to focus on, look at, and make repairs if they are leaking through. And testing valves by temperature method is very, very difficult, which we explained before in part 1. So in the steam valves, we want 5 test points. Basically, we want test points upstream, 2 test points, 2 test points downstream, and 1 test point at the outlet of the closing mechanism, which could be a ball, a gate, butterfly. So we want to be downstream of this shut-off mechanism because if there is leakage, this is where the high-frequency ultrasound will be generated, which we talked about in part 1. So on a steam valve, and this happens to be a regulating type valve, we took our measurements upstream, our measurements downstream, and this is the discharge area of this regulating type valve. So as I was talking, 2 test points upstream, 2 test points downstream, and the last test point is at the discharge side of the valve. Now, testing points upstream and downstream of the valve, what we're looking for is competing ultrasound. If there's any competing ultrasound, that will throw our reading off here at the discharge side of the valve. So what we need to do is benchmark upstream, downstream, the high frequency ultrasound levels, and then go to the valve for the final test point. Not a difficult test, just as long as you follow the testing procedure. Then the question comes is, what is my distance between the valve and my first test point and my second? There's really nothing written that you have to be 10 inches or 24 inches. We want some distance away from the valve so we get a measurement. If the valve is leaking severely, it can throw us off on a reading if we're too close to the valve. So we want some distance. Yeah, we'll say 10 inches. The second should be 24. But this is not written in stone that this is what you have to do. It varies from installations of the valve and what you can do for test points and what you can't do. Now, the reference numbers here that we're using here, you see 25, 24, 25. Those are decibel readings off of the high-frequency ultrasound. So with the newer technology of ultrasonic units, high frequency gives us a decibel reading, and basically we're picking up that reading. Now, on any measurement is that we are taking a baseline, and we're trying to set the unit up to be repeatable. So we're setting the sensitivity of the unit to be at X number all the way through our test points, and then marking down the decibel reading, which was kind of described in part 1. So anyway, I go to my test point 1, I get a measurement of 27, test point 2, 26, downstream 24, downstream 25, and at the valve, 25. So if I went and benchmark this, so I start off at 27, I come down to 26, I come down to 25, come down to 24, and then I come back up to 25. If this valve measurement here is equal to or less than my upstream measurements or my downstream measurements, the valve is seated and not leaking through. So this measurement here at the valve must be equal to or less than upstream measurements or downstream measurements. The thing is, the ultrasound reading I was just talking about must be equal to or less than the readings upstream and downstream. Just repeating, how do we determine that the valve is not leaking through? This here is equal to or less than upstream and downstream. The valve is seated and not leaking through. Now here's a measurement: upstream 26, downstream 27, downstream 25, downstream 34, and at the valve 45. So if I plotted this valve off, comes to 26, and then spikes up to 45, comes back to 34, and comes back. So this tells me this valve is leaking because of the high measurement here. This measurement is greater than my measurements downstream and upstream. So the valve is leaking through. And depending on the variance of this decibel reading versus my measurements upstream or downstream tells me how severely the valve is leaking through. Now here's another measurement. We're taking these baselines here, 21, upstream 25, downstream 57, and another measurement 40, and at the valve is 38. So what does that tell me? So if I benchmark 25, 21, 38, and then 40, and then 57. That tells me the high frequency ultrasound is being generated downstream and is being transmitted back this way here. So this benchmark upstream and downstream is very critical to make sure that we're not getting influenced by something that may be generating high frequency ultrasound. So it's critical to take these benchmarks to make sure we get an accurate measurement here at this valve. So this valve is seated. It has a higher number than upstream, but it has a lower number than downstream. So the valve is seated. Now, the next thing is that we have warm-up valves used all the time. It should be used. And we're using the same procedures that we used previously talked about: upstream, 2 measurements, downstream, 2 measurements, and the third measurement at the downstream side of the closing mechanism, which this one here happens to be a ball valve, so downstream of the ball valve, and go through the same testing procedures. There is a best practice written, so if you want the written documentation, come here to our best practice number 5. Here's our website, and we continue to update, and this video will be posted to the website for your convenience with this technical paper. So a little bit on our company: we do short-term and long-term engineering assessments, reliability, training, implementation, engineering, project design, and steam system changes. My contact information is here, our website, my email, and with that, we wish to say thank you and have a great day.